Okay, so next part we are trying to figure out what is our R, what is our A naught. So the trying to figure out, R and coefficient A, okay, or AM something. So in order to trying to figure out R, we need to go back to our previous equations. So this long term, 1, 2, 3, 4, 5. This term has to be equals to 0, where this term has to be 0, this term has to be 0. All the coefficients for this x to the m plus r plus 2, this term has to be equals to 0. So let's figure out what is r first. Okay. So we have a naught r squared minus r plus r minus 1 x to the r equals to 0. Since this x to the r is not equals to 0, then r squared minus 1 has to be 0. Since a naught won't be 0, that is based on the definition of the extended power series. R x to the r won't be 0 because that is a power functions. So r squared minus 1 equals to 0. R will be equals to plus minus 1. So r1 equals to 1. R2 equals to minus 1. Then let's look at the other term. There is another term including the x r to the 1 r plus 1. So that is a1 times r squared plus 2r. Okay, that is rx to the r plus 1 equals to 0. And since this term won't be 0, so since rx to the r plus 1 is now to 0, and when r equals to plus minus 1, this term is now 0. R squared plus 2r is now to 0. When r equals to plus minus 1 from this equation, then what we can get, then that means a1 will be equals to 0. So a1 can be 0. Only the a naught couldn't be 0 based on the definition of the power series. Then a1 equals to 0. So r equals to plus minus 1. When my r1 equals to 1, then the power series become from 0 to infinity, m plus 1 minus 1, m plus r minus 1, squared am minus m plus r plus 1 times m plus 3 plus r, am plus 2 to the m plus m, x to the m plus r plus 2 equals to 0. So this is the combine the first two terms, 1, 2. So combine these two terms because they all have the common term x to the m plus r plus 2. Then we can get, and the other term will be equals to 0 because here a1 equals to 0, here r equals to 1. So this two term will be equals to 0. Then this power series become like this. In order to like this term equals to 0, this part won't be 0. That means this coefficient part will be equals to 0. So am plus 2 will be equals to m plus r minus 1 squared divided by m plus r plus 1 divided by m plus r plus 3 am. Okay. So this is the relationship between the m plus 2 and the am. And if you can write m equals to 0, 1, 2, until infinity, then you can get basically a2 will be equals to a2 will be equals to 0 times a naught. A3 will be equals to 1 over 15. A1 will be equals to 0 because A1 equals to 0. A4 will be equals to 0 because A0 or A2 will because A2 will be equals to 0. So in the end, this y1 x will be equals to the sum from m to the infinity am x to the m plus r equals a naught x, a naught x. So that is the first solution. Then the second solution for R2 equals to -1. Okay, R2 equals to -1. Forgot to mention that because R1 equals to 1, so that will be written as m squared divided by m plus 2 times m plus 4 am, right? Then since m equals to 0, then this term will become 0 times a naught. A3 equals to this term, A4 will be equals to some A2, but that will be equals to 0. So this whole term will only have the A naught term, which is A naught x to the m plus 1, where m equals to 0, then only left this r equals to 1. So when R2 equals to -1, R2 equals to -1, then this am plus 2 will be equals to m minus 2 squared times m plus 2 am. Okay, so it's the same from here, but when r equals to -1, that will be m minus 2 squared divided by m times m plus 2 am. Okay, and we can also make some examples when like m equals to 0, 1, 2 until infinity, because I'm start with 0. But when you found that when m equals to 0, this a2 will be equals to infinity a naught, because the determinator will be 0 here. Then it doesn't make any sense. So this is not allowed. Then in the end, this R2 equals to -1. It doesn't make any sense. So it's not validate root. You couldn't lead any conclusion based on it. Then what you can do that you can use, so right now, since this R2 equals to -1 is not a validate root, you in the end, you only get one solution of your second order ODE, which is a naught x. In order to get the second linear independent solution, what you need to get second linear independent solution. What you need the reduction of order. Right? You need reduction of order in order to, based on this y1, you can get the y2. Okay? Y2. You need reduction of order. How you do the reduction of order? You can just say, okay, my y2 will be equals to uy1, and this u will be as function of x. Y1 is whatever you get here. Then you can solve this equation one more time using reduction of order and get the y2. Then in the end, the final solution will be a linear combination between y1 and the y2. If you have initial value conditions or boundary value conditions, you can solve it the constant C1 and C2 to get the unique solutions. Okay.